On problem number 3, it asks you to analyze the graph of a rational function, and my rational function is r of x equals x squared minus 9 over x to the 4th minus 16. And then it wants you to analyze it by finding the domain, the vertical asymptotes, and a horizontal or oblique asymptote. Then after all that, it wants you to graph it. Okay, so let's first find the domain. And how you do that is you look at the denominator and you find where there are any discontinuities, which is basically like find where the denominator equals 0, because if the denominator equals 0, then it's going to be undefined there. So we have x squared minus 16. Well, let's go ahead and factor this, but we don't quite know how to since it's such big. So let's use the rational zero theorem from chapter 4.5, and it gets you all the possible rational zeros. So how we do that is we divide the constant, which is at the end, by the leading coefficient, or LC. So we get 16 over 1. And then it's all the factors of the top and the bottom. So we have 1 times 2 times 4 times 8 times 16, because 1 times 16 gets you 16, 2 times 8 gets you 16, and then 4 times 4 gets you 16. And that's all divided by 1, because 1 is only divisible by itself. So now we would actually have to divide this out if it wasn't just a 1, but what we can do is just either plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16. Those are possible zeros. So I'm going to go ahead and let's try using synthetic division to see if positive 2 is 1. So put the 2 over there, and then we plug in this. So we have, and remember, it's like you put the greatest power over here, and its leading coefficient is 1. But then we have to fill in x to the 3rd, x to the 4th, and so on. So then we have x to the 3rd is 0, x to the 2nd is 0, x to the 1st is 0, and then x to the 0 is negative 16. So let me sort of highlight this for you. This is x to the 4th. This is x to the 3rd, its leading coefficient, x to the 2nd, x to the 1st, and x to the 0. Okay, so how we do synthetic division is we first pull the first one down. I'm going to change colors. So we have 1. We multiply it by 2. So we get 2. We add them. We still have 2. Then we multiply them. So we get 4. We add 0 and 4. So we get 4. We multiply them. 8. We add them. We still have 8. Then we're going to multiply them. We're going to get positive 16. Now we're going to add negative 16 to positive 16, and we're going to end up with 0. So since this very last one was 0, that means that 2 is a 0 of our function. So now that we have 2, let's go ahead and pull this down into another synthetic division, and let's actually try negative 2. Okay, so we're going to pull the 1 down, we're going to pull the 2 down, we're going to pull the 4 and the 8. And let's go ahead and do synthetic division again. We pull this 1 down. So 1 times negative 2 is negative 2. We add them and get 0. We're going to multiply them and still have 0. So then we're going to add 4 and 0, and we'll get 4. We're going to multiply negative 2 and 4, and we're getting negative 8. So now 8 plus negative 8 is 0. So since we got a 0 in that last column, negative 2 is also a 0. So now let me go ahead and write this. So this will be x to the 2nd plus 0x plus 4. How did I get that? Well, you see right here, this cut off one of them. So these shifted over, and it was like, this is x to the third, this is x to the second, this is x to the 1, this is x to the 0. But then once we went ahead and did it again, this became x squared, this became x1, and this became x to the 0. So each time you do synthetic division, it sort of shifts the power down. So let me rewrite this one more time. X squared plus 4. We can't factor this. And if I tried to do, say, quadratic formula, I would end up with an imaginary number. So this really just goes away because it's an imaginary 0, and we don't need those. So we found that this right here and this right here are discontinuities. So our domain is everything but these 2 points. So let's write it like this. Bracket x such that x doesn't equal -2, 2, bracket. Now it'll either want you just to write it actually like this, or it'll want you just to plug in -2 and 2. So depending on what you want. Now let's go ahead and find our vertical asymptotes, which is really good because since we know where our domain, like where the discontinuities are in our domain, these right here are actually our vertical asymptotes. So by finding the zeros of our denominator, we were actually finding where our vertical asymptotes are. So I'm going to get a new piece of paper, and I'm just going to write that our vertical asymptotes are x equals -2, 2. Okay, so now let's move on to horizontal or oblique asymptotes. Now, if you remember Bobobot meets DC, we can apply that to figure out which asymptotes we have. Okay, so our equation was x squared minus 9 over x to the 4th minus 16. Okay, so now this is 3 different things. Bigger on bottom, y equals 0. Bigger on top, you don't have a horizontal asymptote, but you have a vertical or an oblique asymptote. And then each DC is if the exponents are the same, divide the constants. So let me start over here. Bigger on bottom, so that means that our biggest power, x to the 4th, is bigger than x to the 2nd, which it is. So this is actually the one we use, and it says bigger on bottom than y equals 0. So that's the equation of our horizontal asymptote. And we do not have an oblique asymptote because we have a horizontal asymptote. Now it will ask you to graph this. And usually, I mean, you can plug it into your calculator and look at it, but also think about the things that you just found. Since we found, let me draw a graph. Since we found that it has vertical asymptotes at -2, so it's got an asymptote here, and it has vertical asymptote here. Those are asymptotes. Let me go over with blue, so you can see the y-axis. Okay. And then now let's plot our horizontal asymptote at y equals 0. So now these are where it can't equal. And I want to graph it real fast just to show you what it would actually look like. Okay. So once I graph it, I see that it looks something like this. It comes down, but it doesn't touch these asymptotes. then it's going to be in here, and it's going to come down like that and go back up. And then one more time, it's going to be in here, but not touching the asymptotes. So that's how you graph it, and it would just have 4 graphs, and you would pick which one. So think about your asymptotes.